So this is what you should have learned in grade 10. Okay, so you said it's acid and base. Okay, so acid, and then base. Okay, so guys, can you keep it down? Okay, so acid is how what? What do we know about it?
Acidic something.
How acidic, what is that? What, do we know anything about what that means in regards to pH? Okay, let's go back. Do we know what the pH scale is?
Yeah.
What's the pH scale?
A scale of
Okay,
the
what
highest number is the most is how much of a base it is, and the lowest number
Okay.
is how acidic it is.
And what's right in the middle?
The neutral.
Okay, and what kind of thing would you describe as being neutral? For sure, for sure. It's the most neutral thing you can think of.
Water.
Water, okay? So H2O goes in the middle. And this, you're right, this is basic. This is the most basic. And this is the most acidic. And as the pH goes from 0 to 7, you're getting more acidic. And as you go from 7 to 14, you're getting more basic.
Mm-hmm.
But what pH is actually caused by is the idea of the amount of hydrogen ions. So what we do is the concentration of hydrogen ions is high when you're acidic, and the concentration of OH ions is high when it's basic.
Mm-hmm.
When you are at water, it is exactly equal. So okay, so the concentration of hydrogen ions is 1 times 10 to the negative 7, and the concentration of hydroxide ions is 1 times 10 to the negative 7. Well, that's a really big number, but that's not important because all we do to find the pH of something is we take the number, get rid of its negative, and right, so the pH, the H stands for hydrogen, is equal to this number, so 7. Right, so the pH is 7 because it's 1 times 10 to the negative 7 is the concentration of hydrogen ions. So over here, if the concentration of, let's not use 0, let's say we're talking about 1, which is like hydrochloric acid, or sulfuric acid, let's say, a super strong acid that if you drank it, you'd die. All right, so it has a pH of 1, so concentration of hydrogen ions, when the pH equals 1, the concentration here is 1 times 10 to the negative 1. And if we look at that, we know 1 times 10 to the negative 1, if we calculate that out, that's actually just 1 times 0.1, just 0.1. That is a pretty big number, right? So 0.1 hydrogen ions, whereas here it's 1 times 10 to the negative 7. So that's really just 1 times 0.00000, right? We just count over how many zeros to negative 7. 6 of them, and then our last number is a 1. So this amount of hydrogen ions is way less. But what's interesting here is it's corresponding. So if this is really a high number of hydrogen ions, the number of hydroxide ions is going to be equal to 1 times 10 to the negative, anybody got a guess? Scale goes from 0 to 14. We're at 1.
1.
No, if it was negative 1, it would be the exact same amount. It's only the same amount here.
It would be.
Here and here, they're together.
Yeah.
Here, it's negative 13.
Why?
So here and here, when you take negative 7 and negative 7 together, you add them up, you get just the 7 and 7 part.
14.
Here and here, you have negative 1 and negative 13, you get.
14.
So wherever you are on the scale, the concentration of hydrogen ions and the concentration of hydroxide ions always together has to be 14. And that means because here, if you go negative 13, you have 0.00000, a bunch of zeros, a teeny tiny amount of hydroxide ions, because there's a large amount of hydrogen ions. Over here, if we're talking about 14, OH minus, okay, so let's say we're talking about a pH of 13, right, which is equivalent as here. The amount of hydrogen ions here we know is maybe 1 times 10 to the negative 13. But the number of hydroxide ions, what do we think it's going to be equal to this time?
-1.
Exactly. So now the hydroxide ions are really high and the hydrogen ions are really low. And that, so what happens if you take hydroxide and hydrogen ions and you add them together?
Isn't it make
It makes water. Okay, so what we say about acids and bases is that anything that adds OH to the solution is going to make that product, the solution,
Neutral?
more basic. Anything that adds hydrogen ions to the solution is going to
More
make it more acidic. But part of the reason it's doing that is, and the reason why you think about it like a neutralization reaction, if you have something that has a pH of 13, it's super, super basic. It could definitely make you sick if you drank it. Let's say you accidentally drink a whole bunch of it. What would we tell you to drink next? It might not save you, but what would we tell you to do? Drink something that's
Neutral?
acidic. The more acidic, like when you'll neutralize those things out. It's also true if you drink something that's
Okay.
basic, you'd also reduce it, but this would be the faster way to do it. Again, do not drink acids and bases. Except you do actually drink a lot of acids, right? Because that's where lemon juice, coffee, almost all the things we drink are going to be acidic. A few things will be slightly basic. Okay, so this is